So लास्ट क्लास में कौन सा क्वेश्चन किया था आखिरी में? We were talking about collisions, right? हाँ, तो क्या किया था आखिरी में राधिका? What was the last thing we did? Impulse. I was talking about impulse and impulsive forces. Right? I was talking about impulse and impulsive forces. I told you that. हाँ, So I told you that there is something called impulse and there is something called impulsive forces. Impulse is a general, is a universal quantity like force and momentum, whereas impulsive force is something very, very specific. Although, since the concept of impulse is having the similar name as impulsive force, so I may end up interchanging the two terms. But we must be very clear in our minds that we are talking about two very separate things. Impulse represents the change in momentum of an object, and an impulsive force is a force having some special characteristics which we have already discussed. Okay? So today I'm going to show you that the law of conservation of momentum that we have discussed, if you remember, uh, there was a special condition when you can apply this law. And the condition was that the external force on the system has to be zero. But today I'm going to show you that the real state or the modified statement is that you can conserve momentum of a system if the external impulsive force is zero. Okay. Okay. So before we do that, let us discuss a couple of questions involving the concept of impulse and impulsive forces. Okay. So the question that I want to talk about is, I will do this, but I will solve this question. Particle of mass m is dropped from a height h onto a block of same mass as shown. Find the speed of all objects just after the collision if the particle sticks to the block. And the question is something like this. The figure is something like this. Sorry. Okay, so I'm going to, the block is going to be, the point particle is going to be dropped onto the block. Now, since the two blocks on the two sides of the pulley have the same mass, we can safely assume that the two blocks are in equilibrium. They are not moving. Okay. So what will happen when the point particle drops onto the block and sticks to it? So when the particle of mass m comes in contact with the block, then what is going to happen is that the point particle will experience a impulsive normal reaction n. And since this impulsive normal reaction on the point particle has been applied by the block of mass m, let me call that block 2, right? All the block is block 2. Because the normal reaction has been applied on the point particle by block 2, therefore by Newton's third law, the point particle is going to apply a normal reaction on the block, right? Basically it means that आप किसी के सर पे पत्थर मारोगे तो पत्थर से उसको चोट लगेगी और उससे पत्थर को चोट लगेगी. Of course, जो पत्थर को चोट लग रही है that will not matter. Similarly, the tension here would become impulsive, and tension here will also become impulsive because tension throughout a string is same, and the tension on the right hand side on the block 2 will become impulsive because the block is under the influence of a vertical impulsive force, right? So the tension will also become impulsive. अगर नॉर्मल रिएक्शन अचानक से इंक्रीज करेगा ब्लॉक 2 के ऊपर, तो ये ब्लॉक 2 नीचे जाने की टेंडेंसी में आएगा. और जैसे ही ये नीचे जाने की टेंडेंसी में आएगा, the tension will also become impulsive, like we discussed in the last class. Okay. Now, please follow me very carefully. Before I start, remember that whatever I am doing here, okay, whatever I am doing here, the results matter. Okay? It is the result that we are after. Okay? We are not, or you may decide not to look at the working of the of the mechanism of the solution, right? Although I will suggest that you do, because in some questions it does come handy, but I have seen very small number of questions where this comes handy. So the result is very important, but the mechanism is not so important still. So what I'm going to do is I'm going to talk about the particle now. So for the point particle. So this is the question, and now we are in the solution part. So for the point particle. So for the point particle, I am going to choose the, although it does not matter, but still I'm going to choose the upward direction as positive. Okay, in fact, I'm going to choose the upward direction as positive on all, for all the blocks, particles. So the normal reaction, the impulsive normal reaction that has been imparted, uh, that the point particle has been subjected to, is in the upward direction. Okay, and remember, I'll just change the slide for a minute. That I told you that impulse is equal to delta p is equal to integral of f dt, or if you want it in simple terms, f delta t, right? Okay. So what I say is, now for the point particle in the upward direction, the impulse due to the normal reaction, the impulsive normal reaction is this. And we also know that this impulse must be equal to the change in momentum. And change in momentum is the final momentum minus the initial momentum. So I am assuming that after collision, the block will be moving with a velocity v downwards. That is what I have to find. Okay, find the speed of all the objects just after the collision. Okay, integral n dt will be equal to final momentum, which I'm assuming is m into minus v. Okay, it's moving down. So please be very clear about the minus sign. Okay, it is moving down. My assumption is that after collision, it will be moving down. If my assumption is wrong, नहीं 2m नहीं होएगा राधिका. I'm only talking about the point particle. I'm not talking about anything else. Only the point particle. Look at only the point particle. Just like the legend of Arjun. Look at only the point. Forget about everything else. The point particle will have an initial velocity of root 2 gh downwards. It sticks to the block, but it is still a point particle. It has an initial velocity of root 2 gh downwards and a final velocity of v downwards. Okay. The second statement is an assumed statement. It may be wrong. If it is wrong, I am going to get the answer as negative. Okay. I'm just looking at the point particle. So what is the physics of the particle sticks to the block? Please don't have any sort of dramatical सिनारियोज इन योर माइंड कि वो गया पार्टिकल और वो ब्लॉक से एकदम मेल्ट होके उसके अंदर उसका एक पार्ट बन गया. नो, नॉट हैपनिंग लाइक दैट. पार्टिकल स्टिक्स टू द ब्लॉक का सिंपल सा मतलब है relative velocity is equal to 0. That means that the two things will have the same velocity. That's it. Okay, nothing more dramatic than that. So if I concentrate my focus on the point particle, the final velocity is v downwards. The initial velocity was root 2 gh downwards. So the impulse integral n dt is equal to final momentum minus initial momentum, which was minus m into root 2 gh. Okay, and then we arrive at for the mass 2. Okay, for the mass 2 takes 1 minute. So sorry. For the mass 2 now, well, I know that the initial velocity is 0, and I also know that the final velocity must be v downwards, right? So I know the right hand side. That's not a problem. What about the left hand side? What about the impulses? Well, again, I'm going to take the upward direction as positive. Okay, and then I'm going to write down, see very carefully, integral t dt. You forgot about the tension wala. In minus integral n dt, right? Nothing to be scared about here. All I'm saying is that these tension normal reactions, they vary or they change for a very, very short amount of time dt, and I don't know how they change. I have no idea how they change, right? So integral t dt simply represents the impulse which is imparted on the block by the tension in this dt duration. And this dt duration, by the way, is the time, is the duration in which the collision takes place, in which the particle sort of, begins to collide and ends colliding with the block 2. So integral t dt, this is the upward impulse, minus n dt, downward impulse, is equal to final momentum. Right now final momentum का मतलब of the block, again 2m नहीं आएगा, हम केवल ब्लॉक 2 की बात कर रहे हैं जिसका मास m है. इसकी फाइनल वेलोसिटी वी आर अज्यूमिंग इट विल बी द सेम एज द वेलोसिटी ऑफ द पॉइंट पार्टिकल आफ्टर कोलिजन. अगर पॉइंट पार्टिकल के लिए हमने v डाउनवर्ड वेलोसिटी अज्यूम करी है तो ब्लॉक के लिए भी v डाउनवर्ड वेलोसिटी होगी माइनस द इनिशियल मोमेंटम व्हिच इज 0. I hope everybody is following this. Again, like I said, the mechanism itself is not very important. Is not going to be very important. The result, however, will be very important. For mass one, okay. Again, I'm going to take the upward direction as positive. Now, if mass 2 moves with a velocity v downwards, then it is guaranteed that the mass 1 will move with a velocity v upwards because they are connected to each other by string, right? And we know that the string is an inextensible object. It cannot be, the length of the object cannot be changed. Length of the string cannot be changed. So for the mass 1, then integral t dt, okay, integral t dt is equal to final momentum mv minus initial momentum, right? Okay. Now, our purpose, remember, is to find v. Our purpose is to find v. Now, if you look at the left-hand side of the three equations, we have got three very weird sort of integrals. There is no way that we are going to ever find the, there is no way that we are ever going to find the value of the integral. हमें मालूम ही नहीं है कैसे चेंज हुआ है t, हमें मालूम ही नहीं है कि कैसे n चेंज हुआ है समय के साथ. तो हम, unless of course somebody gives me the function, तब तो फिर कोई बात ही नहीं है, इंटीग्रेशन कैरी आउट करना है, कर लेंगे. लेकिन जब तक हमें कोई बताएगा नहीं और यहाँ पे कोई नहीं बता रहा है, तब तक हमें ये लेफ्ट हैंड साइड तो मालूम ही नहीं है क्या होने वाला. हाँ राधिका, वेरी गुड. So what do I do then? What do I do to find v? Well, I look. हाँ बिल्कुल सही सर. If I add the first two equations, the integral n dt in the left hand side cancels out. And if I multiply the bottom equation with minus 1 on both sides, if I multiply the bottom equation with minus 1 on both sides, and then I add all the three equations, okay, if I add all the three equations, then I'm going to get a 0 on the left hand side. Okay, adding the three equations, I'm going to get a 0 on the left hand side. And on the right hand side, I am going to get minus 3mv, okay, minus 3mv plus m into root of 2gh plus m into root of 2gh, which tells me that v is equal to root of 2gh by 3. Okay, which tells me that v is equal to root of 2gh by 3. ये आया सबको समझ में? Anything which is hazy or sort of unclear? Okay, chalo. So I'll give you a question. I'm going to change the slide. Please take a screenshot. I'm going to change the slide. हाँ, विश्वजीत ने एक्चुअल सवाल अब पूछ लिया. So Vishwajit is asking, why can't we use conservation of momentum? Why can't we use conservation of momentum? क्या problem है conservation of momentum use करने? Well, if you look carefully, then the moment you start to use conservation of momentum, there will be a problem, and the problem is that that the external force is not zero. There is gravity acting on the system in the vertical direction. But if you remember our discussion from last time, gravity cannot be an impulsive force. It is impossible for gravity to be an impulsive force. So if you look carefully at the equations, if you look carefully at the last wala equation, if you look very carefully at the last wala equation, if you look very carefully at this guy, then this guy can be written as m into root 2gh is equal to 3mv. But this looks exactly like what? This looks exactly like what? This looks exactly like the conservation of momentum. This looks exactly like conservation of momentum. Mass into initial velocity is equal to final mass into final velocity. This looks exactly like conservation of momentum. So the result from this is that you can conserve momentum even in the presence of an external force as long as that external force is not impulsive. Okay? And we are going to have a lengthy discussion on this, so don't worry about it. First, let's try this problem. So on a smooth horizontal surface, balls connected by a string of length L are kept at t is equal to 0. One ball requires a velocity v as shown. Find velocity of the two objects just after the string becomes dot. M M. So the distance between the two objects is A, and this A is less than L. And at t is equal to 0, this guy gets a velocity of v naught, right? So what is going to happen is that this guy is going to move ahead, and when it reaches some point, when the string's length becomes L, right, the string is going to become taut. And if the string becomes taut, then there will be an impulsive tension. So either using this, in fact, I would prefer if only for this question you do use this. So you will say that for the point particle 1, then you will set up an equation like this, and then you'll say for the point particle 2, you'll set up a similar equation. And when you add them up, the left hand side should cancel out, and you should get the velocity of the, right. तो जब तक कि यहाँ आएगा, हाँ, नहीं, जीरो नहीं होएगा ना पाथ, क्योंकि एक्सटर्नल फोर्स तो कोई लगी नहीं है सिस्टम पे, स्मूथ हॉरिजॉन्टल सरफेस पे है ना ये दोनों, एक्सटर्नल फोर्स तो लगी नहीं है कोई सिस्टम पे. चलो करो इसको. I don't think any ball can stop after the string becomes taut. नहीं अभी गलत.
सर एक डाउट था.
हाँ पूछो.
सर जस्ट आफ्टर वो स्ट्रिंग टॉट हो जाता है,
हाँ.
तब वो पार्टिकल येलो पार्टिकल की वेलोसिटी v नॉट कैसे हो सकती है?
नहीं, देखो देखो See, this guy, let's call this guy 1. This guy has a velocity like this and a velocity like this. So let this angle be theta. Then this is V naught cosine theta. Okay, I'm sorry about my diagram. This blue line should be in line with the yellow line. Okay? V naught sine theta. Now, when the string becomes taut, this tension becomes impulsive, and this impulsive tension can suddenly change only this guy. There can be no effect on this guy. Ab karo. Nahin. You can't take the tension component. No. So I'm assuming that this guy is 2. Look, very easy. It's not difficult at all, actually. So for 1, I will take, I will take this direction as positive. Something like that, yes. So, थोड़ा सा गड़बड़ है, but yeah, something like that. So for 1, I get minus integral t dt is equal to final velocity, final momentum. मोमेंटम अगर सीधा कर दो, बिल्कुल सीधा कर दो, कोई दिक्कत नहीं. Minus the initial momentum, which is mv naught cosine theta. And for 2, again we take this direction as positive, and we say that integral t dt is equal to final momentum minus initial momentum. So you see that I can only apply this in that particular direction where the impulsive forces are, right? I know that v naught sin theta वाला जो direction है, उस पे कोई फर्क नहीं पड़ने वाला है. v naught sin theta चेंज ही नहीं हो सकता है, क्योंकि उस डायरेक्शन में कोई फोर्स ही नहीं लग रहा. And if you add these two guys, left hand side will become 0, and you get 2mv is equal to 2mv minus mv naught cosine theta is equal to 0, and therefore we get v is equal to v naught cosine theta upon 2, which is what you would have got if you had conserved the momentum of this object along this axis. Conserve momentum along this axis. Now you can ask, why not conserve momentum along any other axis? I mean, ultimately the external force on the system is zero, so I can conserve momentum along any axis, and you are absolutely right. But if you do conserve momentum along, let's say, the horizontal axis, then you are going to run into problems, because then the components of velocities, इनिशियल मोमेंटम तो आपको पता चल जाएगा एम वी नॉट है, लेकिन फाइनल मोमेंटम में हॉरिजॉन्टल पोर्शन उसका कितना है, बॉल 2 का और बॉल 1 का कितना है, ये आपको पता नहीं चलता है. That will be a big problem. So therefore I will conserve momentum in this direction. And cos theta and everything is actually known to us. It is given to us because this is theta, this is theta. And I know that this side is A, and I know that this is L. So this must be equal to L square minus A square. So cos theta will be equal to root of L square minus A square by L. This will be the final velocity of particle 2. The final velocity of particle 1 will be the vector sum of V naught cos theta by 2 and V naught sin theta. Okay, this is how this question works. Okay, so now I want to move ahead now. अब आगे बढ़ना चाहता हूँ. And I want to talk about polynomials. So I told you that there is a way of classification of collisions where we talk about the classification based on elastic and inelastic collision, right? And I told you that I'll tell you a better way of describing inelastic and elastic collisions, right? And that is what I want to do. So we are going to deal initially with head-on collision, and then we are going to go on to oblique collision. First, let's see the mechanism of collision. So what is happening is that you have object 1 having mass m1 with velocity v1, and it is going to collide with an object having mass m2 and velocity v2. And after collision, the object of mass m1 will have a velocity of v1 prime, and the object of mass m2 will have a velocity of v2 prime. It is our job to find v1 prime and v2 prime. That means that if I give you the values of m1, m2, and v1, v2, you should be able to find v2 prime and v1 prime. Okay. So to do this, what I'm going to show you is the actual mechanism of the collision itself. Okay. So when these two guys collide, I think we discussed this last time as well. When these two guys collide, there will be a deformation. इसका क्या मतलब हुआ? Irrespective of the objects that are colliding, that means वो आयरन के बने हैं या डायमंड के बने हैं या किसी भी चीज के बने हैं, irrespective of that, it turns out that when हाँ, बाद में करेंगे, it turns out that when two objects collide, two objects come in contact with each other, then there is a phenomena which occurs which is called deformation. Okay, whether it is a golf club hitting the golf ball, a more uh, a more visualizable example would be a tennis racket hitting a tennis ball, right? You know that a tennis ball is elastic, so when the tennis racket hits the ball in the duration when it is in contact with the tennis racket will sort of lose its shape. It will get deformed. When the cricket ball hits the cricket bat, irrespective of how hard you think the cricket bat and the cricket ball are, if you could slow down the time, if you could look at the ball actually colliding with the bat, you will see that in the duration of the collision, both the surface of the bat and the surface of the cricket ball actually deform. Okay? So, what is happening here? Well, when two objects collide, the atoms and the molecules of the two objects are getting squished because they want to exist in the same place, right? But they cannot. So they get squished. And when that happens, the intermolecular bonds or the interatomic bonds, they they reduce. Okay, they reduce, and because of this reduction of interatomic bonds, if you imagine these intermolecular or interatomic bonds as little teeny tiny springs, basically the springs are getting compressed. So kinetic energy of the two objects is being converted into potential energy, and this potential energy is being stored in these springs. Right now, this process of deformation continues until what do you think? This process of deformation continues until what happens? What do you think? This process of deformation continues until what? Nahin, no, no. Very good, Vishnu. Until their velocity becomes the same. जब वेलोसिटी भाई वो उसके अंदर घुस क्यों रहा है, M1 M2 के अंदर घुस क्यों रहा है, कोलाइड ही क्यों हो रहा है? क्योंकि V1 की वैल्यू V2 से ज्यादा है, राइट? हाँ, उसका वेलोसिटी ज्यादा है. अब जब वो उसके अंदर घुसा तो V2 की वैल्यू बढ़ता जाएगा एंड V1 का वैल्यू कम होता जाएगा, and this will continue until both their velocities become same, and after that V1 will continue to decrease, V2 will continue to increase until V2 dash becomes greater than V1 dash, and then of course then M2 will race ahead of M1. So the process of deformation continues until the velocities of the two objects become the same, and then the process of what we call in physics reformation starts. That means that all these teeny tiny springs which have been compressed to their maximum value or the maximum they can be compressed in this situation, they all start to now flex back into their original positions. And when this happens, the potential energy starts converting back into kinetic energy. But it may necessarily not convert back into kinetic energy, it may convert back into something entirely different. So, a part of the potential energy may convert back into kinetic energy, while another part may convert back into sound energy, while another part may convert back into heat energy, and so on and so on. So, it turns out that there is a process up till this point when the shape of the two objects is sort of like this squished. This is M1, this is M2. This is the नहीं कोई गैप्स नहीं क्रिएट हुआ है नहीं हम नहीं नहीं कोई गैप्स नहीं क्रिएट हुआ राइट
नहीं
यू
तो
आर
वो अंदर
इमेजिनिंग
घुस जाएगा ना, मतलब उसका
पर घुस के
सरफेस।
वापस आ जाएगा ना, वही तो मैं बोल रहा हूँ।
नहीं सर, मैं जब कोलिजन हो रहा है उसकी बात कर रहा हूँ सर।
हाँ
सर जब कोलिजन होगा तब वहाँ पर उनके बीच में जरा दरारें आ जाएंगी, तो उसमें वही पोटेंशियल
दरारें आ
एनर्जी।
जाएगी, क्या फिजिक्स पढ़ रहा है, क्या कर रहा है? हाँ बिल्कुल, that is yeah, हाँ so the dents that the particles will get, yes, they are the location of the stored potential energy. Yes, यही पूछ रहा है ना, this is what you are asking, right?
हाँ सर।
The dents will, yes, they will, yes. And I'll send you guys a video on the group where you can see this happening. So deformation occurs, reformation occurs, and this is the point. Accidents Shujot are completely different. Accidents में क्या होता है? Well, different तो नहीं है, collision ही है. So if you have seen the aftermath of an accident, जो जो दो vehicles हैं, they are completely smashed. हाँ, they are completely smashed out of existence. No reformation, almost no reformation occurs, right? But जब एक्सीडेंट हुआ होगा तो डेफिनेटली बहुत आवाज आई होगी, हीट जनरेट हुआ होगा, right? So some reformation has definitely occurred, not as much as not 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 100%, not 50%, not 90%. Very small reformation does occur. If reformation does not occur, if the potential energy does not convert back, if the potential energy does not convert back into anything, then we say that the elastic, then we say that the collision is perfectly elastic, perfectly inelastic. Sorry. So this is the point of maximum deformation. This is the point of maximum deformation. Okay. Okay. Now, I want to introduce a new object here. Okay, and this new object is called the coefficient of restitution. The symbol of this object is E. The units of the object are nil, the koi units nahi. And the value of this E can only be between 1 and 0. It cannot be anything else. And the definition of E is that it is the ratio of the impulse of deformation to the impulse of reformation. Okay, now what do we mean by impulse of deformation? What do we mean by impulse of reformation? Well, if the process of deformation starts here, ends here, this is deformation, then the impulse of deformation must surely mean the change in momentum in this process. And what about the impulse of reformation? Well, from here to here, the reformation has occurred. So the impulse of deformation must mean the change in momentum from the middle picture to the right wala picture. But the change in momentum of what? The answer is any one object you can take. Change in momentum of any one object is is the impulse of deformation or the impulse of deformation. Let's work it out. So I know the, for deformation, I know the initial velocities, and for deformation, I am aware of the final velocities. At least I know that they are v1 prime, v2 prime. I may not know their actual values. What I don't know is the final velocity in the process of deformation, or the final velocity in the process of or the initial velocity in the process of reformation. Or do I know it? Do I know the velocity at the point of maximum deformation? Do we know the velocity at the point of maximum deformation? Do we know the velocity at the point of maximum deformation? अगर दो ऑब्जेक्ट्स हैं और दोनों की वेलोसिटी सेम, हाँ सेम होएगा, बिल्कुल सही, सेम होएगा. वेरी गुड अभिजीत, वेरी गुड, एक्सीलेंट बच्चा, एक्सीलेंट, यस. नहीं पाथ, वी डोंट एक्चुअली नीड कंजर्वेशन ऑफ मोमेंटम. अगर दो ऑब्जेक्ट्स की वेलोसिटी सेम है तो वो कौन सी वेलोसिटी होएगी? अगर दो ऑब्जेक्ट्स की वेलोसिटी सेम है, क्योंकि वी आर अज्यूमिंग दैट पॉइंट ऑफ मैक्सिमम डिफॉर्मेशन पे दोनों की वेलोसिटी सेम है. अगर दो ऑब्जेक्ट्स मूव कर रहे हैं such that there is no external force on the object, and then the velocity is same, then we can say for sure, yes, that that velocity will be the velocity of center of mass. So this point, this object, both of them are moving with v, because remember m1 v1 plus m2 v2 upon m1 plus m2 is the velocity of center of mass. And if v1 is equal to v2, then you can actually take v common, and m1 plus m2 ऊपर भी आ जाएगा, m1 plus m2 नीचे भी रहेगा, cancel हो जाएगा, vcm will be equal to v. So if two objects are moving with the same velocity, or three objects are moving with the same velocity, or n objects are moving with the same velocity, then that velocity must be the velocity of center of mass. Okay, so let's write down the impulse of deformation and the impulse of reformation. So I am going to do it for m1. Okay, you can do it for m2 as well, it does not matter. So E is equal to the impulse of deformation. Okay, impulse of, मैंने उल्टा लिख दिया, I'm so sorry, I'm so sorry, I'm so sorry. If you have written in your copies, please change. This is impulse of deformation on impulse of deformation. फाइनल हमेशा न्यूमरेटर में रहता है, इनिशियल हमेशा डिनोमिनेटर में रहता है. So E is equal to impulse of reformation. We are talking about m1. Final velocity of m1 is v1 prime. So this will be m1 v1 prime minus m1 vcom. This is the impulse of reformation divided by impulse of deformation. Final momentum, which is m1 vcm, minus initial momentum, which is minus m1 v1. So m1 cancels out, and I am getting v1 prime minus vcm divided by vcm minus v1. Now, what is the value of this vcm? What is the value of this vcm? The value of this vcm is m1 v1 plus m2 v2 divided by m1 plus m2. But this is also equal to m1 v1 prime plus m2 v2 prime divided by m1 plus m2. I want to put this, I want to substitute this here. Okay? I'll do it in the next slide. So please take a screenshot or write it down. आगे बढ़ो. So E is equal to V1 prime minus Vcm. Okay? So V1 prime minus V0. Now I have two choices for V0. I can either use the upper wala expression, that was M1 V1 plus M2 V2 upon M1 plus M2, or I can use the lower wala expression, which is M1 V1 prime plus M2 V2 prime upon M1 plus M2. I'll choose the second one because V1 prime hai yahan pe. So V1 M1 V1 prime plus M2 V2 prime divided by M1 plus M2. And नीचे VCN के लिए I will choose M1 V1 plus M2 V2 upon M1 plus M2 minus minus V1. Right, and this I can take LCM, and the LCMs will cancel out. And if you look at the numerator, I'm going to get M1 V1 prime plus M2 V2 plus M2 V1 prime minus M1 V1 prime. तो cancel हो जाएगा. So here I'll get M2 V1 prime minus M2 V2 prime upon नीचे M2 M1 V1 फिर से cancel out हो जाएगा, and I'll be left with M2 V2 minus minus M2 V1. So E is equal to V1 prime minus V2 prime upon V2 minus V2. Right, so we can sort of remember this by saying that this is the relative velocity after collision divided by relative velocity before collision. Now you may ask, in fact you should ask, why take this sort of itna lamba route to define E? Why can't we just say that E is the ratio of relative velocity? Well, I wanted to show you something. Exactly. Yes, I wanted to show you something. And something that I wanted to show you, and you should be careful about in the future, is that although I have written the relative velocity after collision and relative velocity before collision, you should ask relative to what? And if you look carefully, you will see that the numerator is the relative velocity of collision with respect to particle 2, and the numerator and the denominator is relative velocity with respect to particle 1. Is this, or can this be, a source of confusion? The answer is no, because we are taking the ratio, and remember that vectors cannot be divided. It is impossible to divide vectors. So basically, we are dividing the magnitudes. And since E can never be negative, so if you are getting a negative quantity, you just drop the negative sign. You just don't look at the negative sign. So is this a source of confusion? No, it is not. So you can simply find the magnitude of the relative velocity after collision between the two objects with respect to any one, and then you can find the magnitude of relative velocity before collision with respect to any one, and then simply divide. Okay, but again, be careful, because on the top, if you have v1 prime minus v2, in the bottom you have v2 minus v1. Right? This is the thing that I wanted you to remember, and therefore I took this longish sort of route to arrive at the definition of E. Once we have the definition of E, then basically everything falls into place, and I don't need to do anything anymore, right? In fact, now you will do the work. I'm going to change the slide. Okay, please take a screenshot. I'm going to change the slide. हमेशा relative velocity होगा, हाँ हमेशा. And I am going to write down here. And I'm going to write down here. From, हाँ नीचे सेम और ऊपर सेम नहीं होगा ना, तभी मैंने इतना लंबा रूट लिया ना डिराइव करने के लिए. I cannot write v1 prime minus v2 prime divided by v1 minus v2. No, that would be, that will give me a negative answer basically. So from conservation of momentum, we get m1 v1 plus m2 v2 is equal to m1 v1 prime plus m2 v2 prime, and E is equal to v1 prime minus v2 prime upon v2 minus v1. Find v1 prime, v2 prime. The answer must be in this form. Must be something v1 plus something into v2. v1 plus v2. Right? Please do this. Lots of algebra for you to play around with. Simple algebra. Please do this quickly. किसका मास? नहीं नहीं, क्यों? कार और ट्रक कोलाइड करेगी तो मास सेम थोड़ा रहेगा. केवल एक बार की मेहनत है. Once you figure out the values in brackets, you will find that there is a very nice pattern. You should be able to remember it. बताओ भाई, कोई तो बताओ। Very nice. देखो, I can rewrite this as बिल्कुल सही। हाँ, पैटर्न दिखाई दे रहा है ना। Sorry. ये आएगा V1 प्राइम। आई होप जिन्होंने मेरे को आंसर भेजा है उनका तो करेक्ट था, बट जिन्होंने नहीं भेजा है आंसर, आई होप यू हैव गॉट दिस। And the V2 prime wala will be, symmetric. So it will be something like so. I don't like to say this. Uh, you have to remember this. You have to remember this. And you have to remember this because you will get a question where collision will be there, and they will be asking something which happens after the collision, which is के बाद क्या होगा. You will not be in a position really to apply conservation of momentum and energy and everything else, and then find what is v1 prime and what is v2 prime. So collision will become a very small part of the question, and all you will need, all you would require would be the velocities after collision, and uske liye, you just have to substitute the values into this equation, and that's it. सबने लिखा ये, सबने किया ये, I hope. बोलो भाई. Okay. Now, all I'm going to do now is going to discuss a series of questions where only this formula is used. Okay, we are going to discuss a series of questions where only this is used. So let's start with a few special cases. M1 equal to M2 and E equal to 1. Let me explain what I'm asking you. मैं आपसे बोल रहा हूँ कि दो ऑब्जेक्ट्स हैं M1 और M2, इनका वेलोसिटी है v1 और v2, और ये कोलाइड कर रहे हैं, और कोलिजन के बाद इनका वेलोसिटी हो जा रहा है v1 प्राइम और v2 प्राइम. ओके, आई एम आस्किंग यू, हाँ वो क्लासिफिकेशन देखते हैं बाद में. I am asking you for the values of v1 prime and v2 prime, okay, given that the initial velocities are v1 and v2, right? So we know v1 and v2, we know m1 and m2. So the answer will be in terms of m1, m2 and v1, v2. Please tell me what will be the value of v1 prime and v2 prime. Simply substitute the values. Put m1 equal to m2 and put E equal to 1, and tell me what are the values of v1 prime and v2 prime. Very good, sir. Yes. Very good, sir. Yes. बाकी लोग just substitute, बच्चा, just substitute. नहीं, विश्वजीत थोड़ा गलत है, अभिजीत बिल्कुल सही है. नहीं विश्वजीत, अभी भी गलत है. हाँ, अब सही. हाँ, बिल्कुल सही. नहीं साईं, गलत है ये. All you have to do is you have to write down v1 prime is equal to m1 minus em2 upon m1 plus m2 into v1. नहीं राधिका, गलत. 1 plus e, हाँ लो सही है, m2 upon m1 plus m2 v2. हाँ पार्ट बिल्कुल सही. So if I were to put m1 equal to m2 equal to m, I would get m minus m upon m plus m into v1 plus 2m upon m plus m into v2. I hope you agree with this, guys. मैंने e का वैल्यू 1 पुट किया है और m1 का वैल्यू m और m2 का वैल्यू m पुट किया है. So this becomes 0 plus 2m upon 2m into v2, which is equal to v2. v1 prime is equal to v2. When you now find v2 prime is, जिस तरीके से मैंने सब्स्टिट्यूट किया है, जिस तरीके से मैंने सब्स्टिट्यूट किया है उस तरीके से सब्स्टिट्यूट करिए. टेल मी द आंसर. हाँ, v2 prime is equal to v1. So if masses are same and E is equal to 1, velocities get exchanged. Very, very weird, very, very weird phenomenon. Next. Please take a screenshot of this. हाँ, कोई बात नहीं, फिर से once again. अच्छा है ना, 2 बार आपने कर लिया तो एटलीस्ट याद तो रहेगा. हो गया, स्क्रीनशॉट ले लिया, आगे बढ़ूं मैं. Everybody has taken a screenshot, right? M1 is equal to M. M2 is equal to infinity, which is another way of saying that M2 is much greater than M1. E is equal to 1. अब बताइए क्या होएगा. हाँ, V2 is क्या? V1 V2 की वैल्यू चाहिए मेरे को. नहीं, V2 is 0. हाँ, V2 dash is V2. Yes. नहीं पार्थ, ना, गलत. How can we move infinity? Infinity नहीं है ना यार, वो मैं infinity symbol use कर रहा हूँ, but what I really mean is a very large object. नहीं वेदांत, गलत है. ये मेरे ख्याल से सही नहीं, ये भी गलत. क्या हो गया भाई? नहीं, देखो. V2 dash, I hope सबका V2 आ रहा है, इसमें कोई फर्क नहीं, क्योंकि एक बहुत बड़ा ऑब्जेक्ट अगर मूव कर रहा है and it collides with a small object, then its velocity will not be affected. Although I'm not making this as as a theoretical statement, this has to be derived. This V2 has to be derived. I'll do it in a moment. V1 prime is equal to M1 minus EM2 upon M1 plus M2 into V1 plus M21 plus E upon M1 plus M2 into V2. Yeah, you see what is going to happen. So I can neglect M2. I can neglect M1 basically. Right? आया समझ में सबको? अगर कोई स्टेप नहीं समझ में आ रहा है, you have to ask. I am simply substituting the values. So M2 is equal to infinity. That means M1 I am going to neglect completely. I am going to put it as 0. So if you look, ऊपर भी मैंने 0 रखा, नीचे भी 0 रखा. ये क्या चीज है? What is this? Anybody guess ये है क्या? M1 plus M2 equal to M2 होगा. हाँ बिल्कुल. M1 plus M2 equal to M2 होगा क्योंकि 1 करोड़ plus 1 is roughly equal to 1 करोड़. 1 करोड़ plus 1 is equal to 1 करोड़, right? Roughly, approximately. M1 plus M2 will be equal to M2. Now, the first question asked was ये M2 infinity कैसे हो गया, right? Let me give you an example. When I say M2 is infinity, I of course don't mean that the mass is infinite. What I mean is that the mass of M2 is much larger than the mass of M1. Now, a prime example of this is a cricket ball and a cricket bat. Because it is not only the mass of the cricket bat, but also the mass of the batsman, which is going to be M2. Okay. Ratio of M2 by M1 will be a very large number, yes. But ratio of M1 upon M2 will be 0. Ratio of M2 upon M1 will be a very large number, but the ratio of M1 upon M2 will be 0, as I have done in V2 prime. पहला वाला जो. So mass of the cricket bat plus the batsman is M2 and mass of the cricket ball is M1. Okay. Now look at the velocity acquired by the cricket ball when it collides. So the velocity acquired by the cricket ball is the opposite of its own velocity plus, it is more important, twice the velocity of the bat. Okay. So when this ball collides, when this object of mass m1 collides with this heavy object of mass m2, its own velocity is going to get reversed, number one. And number two, it is going to acquire an additional velocity which will be equal to twice the velocity of the mass m2, right? In fact, this is what happens. अगर आपको मैं बोलूं कि क्रिकेट पिच में खड़े होके एक बॉल को फेंको, स्टेडियम के बाहर चली जानी चाहिए. you will never be able to do that. Okay? You will never be able to do that. But if you have a fast bowler bowling at you, then perhaps it is possible. Why? Because let's say that a ball arrives at you with a speed of 100 kilometers per hour. And let's say that you are striking the ball and your bat, of course, you are striking the ball with your bat, and your bat at that time is moving with a velocity of 50 or 60 kilometers per hour, then the ball will acquire a velocity which will be opposite of 100, that is minus 100, plus it will acquire a velocity which is twice the velocity of the bat, so that will be another 100 or 120. So the ball will go with a velocity of 200 or 220 kilometers per hour. And that is how batsmen are able to hit things out of the stadium. Now, if you remember, if you have played, anybody who has played tennis or has played golf or has played cricket, you know that there is something called the follow through, right? What does this mean? It means that when you are swinging your bat or your racket or your club, and the moment you hit the ball, okay, you do not stop. ऐसा नहीं है कि आपने बैट घुमाया और जैसे ही बॉल से कांटेक्ट बैट हुआ आपने बैट छोड़ दिया, हाँ ठीक है मैंने तो मार दिया, मैं चलता हूँ यहाँ से. No, it does not work like that. You have to follow through. You have to move your bat along the whole path. And the reason is that you want to maintain the velocity of object 2 at V2. तभी ये इफेक्ट आने वाला है. अगर आपने बैट छोड़ दिया या आपने क्लब को छोड़ दिया तो इफेक्ट नहीं आएगा. ठीक है ना? चलो ठीक है. We'll continue this discussion in the next class. In the next class, remember, only the application of this formula will be done. Okay? So before we start the next class, please remember to have your copies open with this formula, with these two equations. Okay? Chalo. So we'll meet in the next class. ठीक है? Okay. Bye bye. Bye 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 bye. आधे लोग सो गए लग रहा है मेरे को. इतना बोरिंग भी नहीं है. नहीं पार्थ, अभी ऑफलाइन का कोई न्यूज नहीं आएगा तो अपन शुरू करेंगे. ठीक ही है. देखो रजत ठीक ही था ना रजत. हाँ 0 है. हाँ पुष्पक सर की क्लास है. पुष्पक सर आपकी क्लास है?
हाँ सर.
मैं आपको होस्ट बना देता हूँ.
ओके सर.
बच्चों को दे दीजिएगा 5 मिनट 10 मिनट रेस्ट ले लीजिएगा.
हाँ ठीक है.